Dear, dear student, we will start together our journey with physics, but at the beginning I want to tell you physics is a very simple branch of science. It's a good opportunity for you to learn how to think, not only how to think, but how to think properly. Now let us move together to start our journey with physics with the first phenomena about physics to understand the variety between the phenomena of physics. Let us move to the starting point now. This is chapter 1, lesson 1, the physical measurement. But at the beginning, before understanding what is the meaning of physical measurement, you need to ask yourself a very important question, which is called, what's physics? What is physics? Try to think with me. What's physics? Okay, we will move to the next slide to understand what is physics. Physics is a very important branch of science. It's the most important branch. Why physics is called the most important branch? Because on it the other branches of science depends on it. So physics, it's of course a branch of science which interested in studying the phenomena around us. Physics helps you to understand the environment around you. By studying physics, you will understand everything in your environment, about the universe, about even yourself, about the variety between the phenomena around you. So now let us put a specific definition about physics. Physics is a branch of science which seeks to understand and explain all the phenomena around us on the earth and in the space. This is what is the meaning of physics. But if you want to ask yourself why physics is called a practical science, it isn't like history, it isn't like geography, but physics is a practical science. Why physics is called by this name, physical science? This is called practical, which equals to physical science. This due to this science depends on a very important process which should be very, very accurate. Physical measurement. The measurement process should be very accurate, should be depend on a specific measuring tools to be more accurate, of course. So now let us think together, what is the physical measurement? Physical measurement, for example, imagine with me you cut a flu. Of course you wanted to go to see a doctor. If the doctor told you that your temperature is high, that's it. Ask yourself, this answer is really accurate answer? You will be satisfied from this answer from the doctor? Of course not. The doctor should be very accurate, should tell you about the value of your temperature. So the doctor should make physical measurement by using the tool. So physical measurement is very important in this case. Now we need together to understand what is the meaning of physical measurement. The doctor will tell you your temperature equal 38 Celsius degree. Then your state is okay, you are fine. Now let us analyze this definition. Temperature equal 37 Celsius degree. This sentence consists of 3 parts: temperature, numerical value, and the measuring unit. So here you are making a comparison process. This comparison process between two physical quantities. The first is called temperature. This is a physical quantity. The next, Celsius degree, it's another physical quantity. Now you are making a comparison process between temperature and Celsius degree. So by making this comparison, you want to know this number 37. So we are seeking to understand how many times the temperature contains the Celsius degree. Now we can say that the physical measurement, it's a comparison process between two physical quantities. The first, it's the temperature. Of course, this physical quantity is unknown physical quantity. The Celsius, we all know the Celsius. So the second one is known. So this is a comparison process between two physical quantities. The first is known quantity. The second is unknown quantity. To know how many times the first includes the second. This is the physical measurement. Now let us move to the next point about the keys of the physical measurement. Physical measurement consists of or contains 3 elements. The first element, it's a temperature, which is called the physical quantity. The next key, it's the measuring unit. The third key, it's the numerical value. So it consists of 3 keys, which we will discuss together the 3 keys to understand that. Let's move to discuss together the first key. Okay, here are 3 keys. As you see here, we have 3 keys about the measurement process. Number 1, the physical quantity. Number 2, the measuring tool. Of course, you need the measuring tool to measure this number. As we said in the previous example, your temperature equals 37 Celsius degree. So 37, you need a measuring tool to catch this value. And the last key is the measuring unit, as you see here. We will discuss together the first key, which is called physical quantity. We can classify the physical quantities to 2 types, 2 big types. The first type is called fundamental quantity and the derived quantity. What is the difference between fundamental and derived? Try to think with me about any example about quantities around you. You can measure it. Try to think. You will find many quantities around you can measure, like time, like your tall, the length, like the height of your room, it's another length, about your mass, your weight, the speed of your bicycle or the speed of your car. All of these are called physical quantities. But try to ask yourself about the difference between these two types. What about the difference between mass and weight? If you want to know about your mass, you will do what? Okay. If you wanted to know about your weight, you will do what? Of course, if you want to understand about your mass, you will use a balance to tell you about your mass. So, measuring tool will tell you about your mass. But what about your weight? Your weight, you studied before that weight equal mass times acceleration. Weight equal mg. So mass has no smaller quantities inside it, but weight contains inside it smaller or sub-physical quantities inside it, which is mass and acceleration. So mass is part from the weight. So mass is called fundamental quantity. Time. If you wanted to know about the time, you can't use the mathematical equation, but you will use the stopwatch. The length. You can't use mathematical equation, but you will use the tap meter. So mass, time, length, all of these quantities are called fundamental quantities. Fundamental quantities is the quantities which can't be defined in terms of other quantities like length, time, and mass. But weight, velocity, all of these quantities are called derived. Why? Because you can find mathematical rule which define this quantity. This quantity contains inside it another quantities like volume, for example. Can I ask you volume? If you wanted to calculate the volume of your room, you will do what? Do you have a device, measuring tool, can tell directly the volume of your room? Of course not. You can't find this measuring tool, but you need to use mathematical equation. Volume equal length times width times height. So volume contains inside it three lengths: length, width, and height. So volume is called derived physical quantity. What's the derived physical quantity? It is a quantity which can be defined in terms of another quantities, another fundamental physical quantities. This is the physical quantity. The physical quantity is a quantity. We can use either measuring tool or mathematical equation to calculate it. This is the first key, the physical quantity. Now let us move to the second key, which is called the unit of measurement. Why the measuring unit is very important? If you ask it yourself, what about the height of your room or your length? And I told you, for example, the height of my room, it's only 10. Or today I walked for only 100. Without measuring unit, do you can understand anything? Of course you can't understand anything. Why you can't understand? Because if I told you, for example, today I walked for 100 meter, there is a big difference between 100 meter and 100 kilometer. It's a very big difference. So without measuring unit, the measuring process is meaningless. There is no meaning for the measuring process without the measuring unit. The measuring unit is the unit which tell you about the meaning of your process. The measuring unit is making you understanding about what you do. So the scientist cared carefully for the systems of the measuring unit. We will study, as you see here in this slide, the systems of the measuring unit for length, mass, and time only. These are the fundamental quantities, as we said before. We have here three systems: French system, British system, and metric system. First, the scientist used the centimeter to measure the length and gram to measure the mass, and the second to measure the time. And they used these measuring units because the magnitudes of the quantities were very small. After that, they thought to measure larger quantities, so they sought in using the British system. British system, they used the foot to measure the length, pound to measure the mass, second to measure the time. And after that, the scientists thought to make the metric system. Its abbreviation M.K.S. Why this exactly? Due to they used meter to measure the length, it's M, kilogram to measure the mass, it's K, second to measure the time, it's S. So MKS, meter, kilogram, and second. The British system, FBS, F foot, P pound, S second. And the French system, it's a Gaussian system related to the scientist, and we can make an abbreviation for this system. It's a CJS, C centimeter, G gram, S second. Now we will move to discuss together a very important point. Let us move to the next point. Dear student, now we will discuss together a very important difference between the measuring units. For example, if I told you that the measuring unit of mass is kilogram, this kilogram, kg, is called a name. This is a name. The weight. What's the measuring unit of weight? You will tell me Newton. Newton is the measuring unit of the weight. So these physical quantities has a measuring unit. This measuring unit has a name, like kilogram, like mass, mass kilogram, like Newton for weight. What about the temperature? Its measuring unit is Celsius, Kelvin. All of these are called names. But if I asked you what's the measuring unit of speed, the measuring unit of speed is meter per second. It isn't a name. Speed has measuring unit, but this measuring unit has no name. Meter per second isn't a name. What's the measuring unit of acceleration? It's a meter per second squared. It isn't a name. So there are two types of measuring units. Measuring units have a name like Newton, like kilogram, like Celsius, like Kelvin, and another quantities that have no name like meter per second squared. Now I want to put a definition for the mathematical equation to understand it carefully. Due to, I told you before that the fundamental quantities, if you want to know about it, you have to use a measurement tool. But the speed, the acceleration, the weight, you need to use a mathematical equation. Like, for example, your speed equal distance over time. Your acceleration equal velocity over time. Weight equal mass times acceleration. So all of these are called physical equation, mathematical equation. What is the meaning of mathematical equation? Try to think with me, try to learn how we can make the definition. Equation. Weight equal mass times acceleration. What is this? What's the meaning of equation? Equation is a very short explaining, is a shorthand relation. Help us to understand the relationship between the parts of this relation. For example, weight equal mass times acceleration. This means if the mass increased, so of course the weight will be higher. Speed equal distance over time. So if the distance increased, this means your speed is really high. So by using the mathematical equation, you can understand the relation between the physical quantities. And each equation has a particular indication. This indication is called physical meaning. That what I told you about it now, it's directly or inversely. If the time increased and the distance decreased, this means your speed is very low. So I understood all of these details from the mathematical equation. Now you can say that the mathematical equation is a shorthand illustration for the relationship between the physical quantities to catch or understand the physical meaning. Now let us move to a very important system about the physical measuring units. To understand it carefully, let us go to it. Dear students, this system in front of you is a very important system. This system is put by a very famous scientist which is called William Thomson. This British scientist was very intelligent to put this system because he developed the previous metric system to put more physical quantities in it. As you see here, we have 7 physical quantities and 2 addition. So the total physical quantities in this system about 9 quantities, 7 main and 2 addition. Of course, the first is the length. Its measuring unit is meter, m. Don't get mixed between the symbols of physical quantities and the symbol of the units. Length is capital L, meter is a small m, mass big M, and kilogram kg. time big T, second small s. Electric current intensity, you studied it before. Its symbol is capital I, and its measuring unit ampere, A capital. Absolute temperature is the temperature. It's a big T, and its measuring unit Kelvin, big K. Amount of material, this is number 6. Its symbol is N. Its measuring unit is mole, MOL. You will study this quantity in details with your syllabus about chemistry. Luminous intensity. Luminous intensity, it's I small v. Don't get mixed between electric current intensity I and the luminous intensity IV. Here, the measuring unit of IV, luminous intensity, is called candela, CD. This candela, this name came from an ancient source of light. Try to think with me about source of light, an ancient one. Its name close to candela. Try to think the name which close to candela. Can you catch it? Think. Yes, it's a candle. It is a candle. It's our candle. It's an ancient source of light. So from it we took candela, CD. These are the 7 main physical quantities, and we have here 2 additional physical quantities, angle and solid angle. What is the difference between angle and solid angle? Angle has 2 dimensions, solid angle has 3 dimensions. Angle, its measuring unit is radian, as you see here in this slide. And solid angle has 3 dimensions, its measuring unit is T radian. This is the difference between angle and solid angle, and you will study more details about the difference with the syllabus of your geometry. This is the International System of Units. Its symbol is SI, International System of Unit. But here, don't get mixed between International System and its abbreviation SI. You may ask yourself why we didn't make it IS instead of SI. This due to the most of these systems related to the French system, because the French people are the first society which tried to put systems for the measuring units. So it's a source, then the source name of the international system in French, its abbreviation is SI. They start in French with system first and then international. So it's SI, not IS, because this is the source, the French source of this name. Now let us move to a very important another point to discuss together. Thank you for your effort with me. Let us move. Dear students, before our moving to the next key about the physical process, which is called the measurement tools, we want to discuss a very important point, which is the efforts of the scientist. Don't think that the result of science which we are studying here, we caught it by an easy way, but the result here you study it by an easy way due to we have a very famous scientist like William Thomson and Ahmed Zewail. These scientists made a great efforts to find these values to help us to understand about our environment, to give us a cause to thank God about the great, important and charming environment around us. Without the efforts of these scientists, you can't understand anything about your environment. So be grateful for these scientists. First, William Thomson, this British scientist, developed the metric system and found what is called absolute zero. To understand what is the meaning of absolute zero, you studied before something is called Celsius scale and Kelvin scale. If you wanted to convert the value of temperature from Celsius scale to Kelvin scale, you have to add 273 point. If I asked you 0 Celsius equal how many Kelvin, you will add 273. So 0 Celsius equal 273 Kelvin. What about the boiling point? 100 Celsius degree. 100 Celsius degree on Celsius, we will add 273, so we can convert it to Kelvin scale. So 273 plus 100 equal 373. What about the 0 point on Kelvin scale? 0 point on Kelvin scale equal negative 273 on Celsius scale. So negative 273 plus 273 equal 0. This is called the absolute zero, which is found by William Thomson. Ahmed Zewail is one from the famous Egyptian scientists. He used the laser to study the mechanism of chemical reaction among the molecules by using something is called femtosecond. Femtosecond, it isn't a measuring unit of time, it's a measuring unit of length. He used this very small length about the wavelength. You will study this quantity next year in physics. As you make a wavelength of light, like laser light, you can see the structure of the virus, the structure of the microbes, so we can make a cure for this virus or this bacteria. So we thank these scientists for their efforts for make our life more comfortable. Now, dear student, let's start together our discussion about the second key of physics, which is measurement tools. Of course, we can't measure mass without measuring a tool, without level, without balance. You can't measure time without a stopwatch. You can't measure length without the tap meter. And we have today modern physical measurement tools to measure the physical quantities. But at the beginning, in ancient eras, the man has no measuring tools like these we have today. So they tried to use an ancient tools to measure the length and the time. They sought to use the body boards to measure the length. So they used first the arm, and they found it isn't accurate. They tried to use hand span, and the foot to measure the length. But of course, these tools aren't accurate. They tried to measure the time by using the day boards. They used to measure, for example, the sunrise, the sunset as a measuring tool. If you asked me from 1,000 years from now, what's time now? I'll tell you it's daytime or it's night time. And they used also the moon phases to measure the time during the month. But they seek to make the measuring tools more accurate, because our science always tried to develop itself. So they tried to develop the measuring tools first, of course. Now let us move to discuss this with more details.